In this module, we'll continue with our small experimental project integrating various construction systems. This will allow you to see how you can make use of ArchiCAD's tools and objects to simulate different types of construction solutions. Make sure you have your project open up and close by so you can follow along properly. And as always, feel free to pause and replay the video as many times as you need. And remember that each lesson will include additional material provided continuously throughout the lessons. With that said, let's get started. Alright, so for this next part of the section, we are going to focus on the modeling of the diverse types of constructive systems. In the previous part, we already solved the foundations, the columns, the primary and secondary beams using diverse types of tools, techniques, and in this case we are going to do the same for the 6 different examples we got over here. We might also comment extra few tools on how you can model extra things, but in this case the primary focus is going to be the covering of the tools, techniques, and methods we can use to model out the constructive system. So what I'm going to ask you is to open up the saved structure you got so far, and in the next lesson we will start off with the first example, which is going to be based off the steel deck type of slab. Now in ArchiCAD, the easiest way to simulate a steel deck type of slab would be with the use of an object. Let's select the object tool over here. Let's go to the parameters, and right over here in cladding, you can notice we got this type of object called the profiled sheet. So what you can do is straight off jump into the profile settings, and over here you will notice you got different types of profiles that you can use to simulate pretty much the steel deck, or something we're going to do in a little bit, which is also the metal sheet roofing using this type of profile. But for this case, let's go with the base type of steel deck. You can specify which type of size you want to use. You can specify the thickness, which is going to be something really low for this case. Let's go with the pattern angle. You have the shift pattern, and then you got the different measurements you require for the project. Now the measurements will also change depending on which type of country you are located in, so feel free to specify these measurements however you see fit, however you want. For my case, what I usually do, I simply switch the height for the wave a little bit, because this is more closer to the standards we use in Mexico. So for this case, feel free to take as much time as you need to specify your profiled sheet. Now you also have the pivot and edge parameters over here in case you need some type of slant for your profile sheet. This is something we're going to do in the final lessons of this section, where the metal roofing is going to have some type of slant or angle over here. So you can specify everything on this group, and you also have the cutting planes. This is especially useful if you want to make some type of cutaway on one of the borders, on one of the edges for your profiled sheet. Now in this case, I'm just going to let it be as it is. Let's press OK, and let's go to the level 1, the first story we got over here, and you can simply press left click to position your profiled sheet. So if you notice over here, we got this object. Now what you can do is simply start defining how you want to position your object. Now keep in mind that we also need to respect the direction or the span. In this case, we got the primary beams over here, then we have the secondary beams, and if I remember, the profile sheet is always positioned perpendicular to the secondary beams. Okay, so in this case, make sure to keep this small detail in mind. And over here, you can notice how the profile sheet will have a little bit of too much of a thickness. So what I'm going to do is maybe I'll adjust this just a tiny bit, maybe make it really small, something as this. Okay, or even more smaller, something as this. Okay, so I leave the thickness once again up to you. Just make sure that it's set to something close to reality. And in this case, let's open up the section view. Let's see, we got the profile sheet within the section view range. So I'm just going to move this a little bit over here. So if we got the section over here, the profile sheet should be now visible. And in the section view, make sure to adjust the height for your profile sheet until it positions on top of your beams. Okay, now in 3D what we can do is many things. You can, for example, select your profile sheet. You can click one of the corners, to specify, for example, the slant angle. You can also click one of the corners to start extending the profile sheet until it covers the whole area. There are many different nodes the profile sheet has, so you can mess around with the nodes, okay? And you can also do so in the story or the floor plan view. For example, we got the profile sheet over here. We can position it to the center. Don't worry too much about these small details, something we're going to fix in a little bit. And select one of the borders, specify the length, click on one of the borders and specify also the length by width, okay? We can also take maybe this corner, maybe offset it over here and move this corner until it covers the whole area. Okay, so in this case, you will notice we got the profile sheet correctly positioned, and there we have. Now, if you remember something we did that was really important in the previous part of the section, we specified that the columns will have the air material. And thanks to the air material, now what we can do is simply use the solid element operations to maybe simulate a cutaway for the steel profile. Okay, so let's select this element, right click it, maybe do the connect command over here, solid element operations. So this object is going to be the operator and the column is going to be the target. So let's keep it simple, let's keep it just as a subtraction. So the air material is going to subtract some part of the steel profile. And let's see if we execute this operation and let's see how it behaves. So yeah, maybe we don't have too much of a change over here. In this case, what we can do is always seek to open up this profile, maybe increase the priority of the material. So I'm going to do these two things. I'll maybe check out once again the profile, make sure that we have material. Let's see, we got the complex profile over here, which is this one over here. Okay, let's hit the edit button and let's see if we got the airspace material, so everything is working fine over here. And let's go to 3D. Now in second place, I'm going to check out maybe the material priority, something we covered in the very beginning of this course. So in this case, let's make sure that airspace maybe is set to the maximum, because pretty sure that we also have, for example, the steel stainless, and steel stainless has a really high priority. And if I remember, we set the airspace material priority to be 900. So it was set to be below the steel material. So this is the reason why it might not be working properly. So let's make sure that this one sets to the maximum. Press OK. And now let's see if it works out. Well, we still have some type of issue. Let's see if we can subtract this once again. Alright, so for this case, if you are going to check out once again, I had a small issue going on over here, but select the object, and before you once again repeat the solid element operations, make sure to select the steel profile and click the clear all targets and clear all operators button over here. So it's set to be completely reset. And let's try once again. This one is going to be the target, the column is going to be the operator, and just in case, this is just a small just in case, subtraction with upward extrusion is going to be set to be the operation. Okay, just in case. Let's press execute, and right over here you will notice that this is how you can make a small cutaway for your steel profile. Okay, now this is something really small that we might even let it be as it is, because this is usually considered within the budget as a waste percentage of material, so it might not be that important. But if you want to make it as real as possible, let's clear all operators and targets once again, select the steel profile. In this case, this one is going to be once again the target, and select the 4 columns or elements that are intersecting with these elements. These are going to be the operator, execute, and in this case you will notice we got the cutaways going on over here. Okay, now you also got a second manner on how you can create a cutaway. If you select the object and go to the parameters, you can always mess around and play around with the cutting planes. Let's say maybe this distance is going to be 3 meters at an angle of 45 degrees. Press OK. So you can notice that it's going to automatically create a diagonal type of cutaway in case you require something a little bit more specific, in case you maybe have some type of diagonal axis going on over here for your building. If you're wondering how you can create a cutaway, just mess around with these parameters for the parallel view category over here. In this case, I'm going to reset it, set it to 0 and 0, press OK. So it stays just the consideration for the waist of the column. So let's go with the next step, or the last step, which is going to be the easiest one. We also need to simulate the concrete that is going to be poured on top of the steel profile. So this is really easy to fix. Let's select the slab over here. Let's set it to be a basic type of structure. Go to the definitions. I'm just going to set the width or the thickness for the slab over here. As always, feel free to specify whichever type of measurement you want to use according to your own structural or constructive criteria. Okay, in this case this is going to be concrete structural. Let's set the reference plane to be on the bottom, and everything is looking good. Let's press OK. Let's cover once again the whole area with just a basic slab, which is going to be of concrete. And in this case, yeah, let's see if in a cut section if the slab is positioned correctly. So yeah, it's completely positioned correctly, right on top of the beams. Okay, so having done this, let's go ahead once again. Be careful how you select your objects. Maybe you can temporarily right click on the slab and hide the selection. For example, select this steel deck profile once again. This is going to be maybe the operator. Right click it and show everything once again, so we can visualize the slab once again. And now carefully select the slab. This one is going to be the target, and the subtraction is going to have a downward type of extrusion. Okay, let's hit the execute button over here, and with this you can see that we have correctly executed the operation in order to simulate this constructive system. Okay, now the only thing that we are still missing is to consider maybe selecting the slab. We can do a subtraction over here, and pretty much a subtraction for the 4 corners of the column. And there we have it. So we got the slab, which is completely modified for the 4 corners, and also has the shape we require for this type of constructive system. Okay, so if you notice, the steel deck type of slab is quite easy to execute. You just use this object and you cover the whole space with an area. Now, if you want some type of alternative, let's say you don't have the object, you can always go ahead and solve this same type of constructive system with the use of the profile manager. So pretty much what you do is create a new type of profile. Let's hit the new button over here. Let's set this to steel deck profile. Okay, this one is going to be completely new. Steel deck profile. Let's press OK. And you simply go ahead and draw the shape for your steel deck profile. Make sure that it's as precise as possible. Once you are done with your steel deck profile, you simply use this type of profile with your favorite tool, which can be something as a beams, maybe some type of wall. In this case, the beam tool will work a little bit better with this profile. Okay, I just drew it really fast just to make a quick example, but let's say you draw your shape with a little bit of time and extra care. Once you are done, you can simply save the selection and go ahead and extrude this type of profile with any type of tool. So the second alternative in order to solve the steel deck profile would be to use the complex profile tool. Or the first one, which is the fastest and the easiest and the most practical, you simply go ahead and use the profiled type of sheet. Alright, so having solved the steel deck type of slab, let's go ahead with the next example. I'm just going to delete maybe these beams over here. Now the waffle structure, or in other words, the two-way ribbed slab, if I remember well the words in English, it's easier to say it as a waffle structure. Let's go ahead to the level 1 floor plan view over here. And you will notice we got the measurements for the opening, which is going to be something as this. Now it's simply as an example, as an experimentation, so you can understand how we can solve this in multiple ways. As always, feel free to adapt this, integrate this to your own project. But in this case, we are going to use everything as centered as possible. Okay, we need to insert a reference line here, a reference line here, and then we can simply create a basic slab, a basic concrete slab, then create an opening which is going to have 60 by 60 on the centered part, and is going to have 80 by 60 on the lateral parts, on the top part over here and on the top part over here, and everything is set to 60 by 60. And also for the width, we can go ahead, make it 30 in height for the opening, and then maybe 8 centimeters for the top part of the slab. Okay, so let's make it in total 38 centimeters, which is going to be the thickness for this slab. So let's go ahead, let's open up the floor plan view. Just going to pick up the parameters for the slab we used in the previous example, and let's make the thickness to be 38 centimeters. Let's press OK. Let's once again draw the slab from here to here. Just going to take maybe a second, just make a subtraction for the corners. And now, having created the base slab, which looks something like this in 3D, let's go ahead and work on our opening. So for this case, what we need to do is, in first place, let's create a reference line over here. Let's create a second reference line over here. And let's create the first opening. So for this case, the easiest way would be to use the opening tool. This is one of the techniques you can use, or one of the tools in order to solve the openings. We just need to adjust the opening. The second way on how you can also create an opening would be if you take maybe individual set of slabs over here, which are going to be 60 centimeters by 60. Press enter, and then let's see how much we got of a separation going on over here, which is something as 10 by 10. So then we can simply press Ctrl U to multiply everything using the matrix method. Press OK, and right over here, which is going to be 70, we simply go ahead and multiply this small slab. So pretty much you create a bunch of slabs over here. Once you are done, you can even group them, create the main slab over here, and you can simply go ahead, position the openings a little bit over here, and go ahead and use the solid element operation. So pretty much you select the main slab, connect it, solid element operations. This is going to be the target. These slabs are going to be the operator. You create a downward type of extrusion and execute your element. And simply set these openings to be positioned on the hidden layer. So this is one of the techniques you can use also to solve this type of slab. But in my own perspective, I believe that using openings is a little bit easier. If for some reason you don't want to use the opening, you can always go ahead and use the solid element operations technique in order to solve this type of slab. Okay, so let's go ahead with the second type of method, or maybe in this case the first method. What I'm going to do is, in my main slab, I'm going to create an opening which has 60 by 60 and maybe 0.30 in height. Okay, let's see if we can position something as this. Let's start adjusting the opening in 3D, because if you notice over here, it's going to intersect the whole slab. But what we need to do is we need to adjust the height to subtract 8 centimeters. So make it minus 0.30. Okay? And if you notice, this is a little bit more direct because now we don't need to create and then hide the elements. You just create the opening and then go ahead and simply copy this multiple times. So this is basically what I'm going to do. I'm going to take somewhere around 2-3 minutes and I'm going to create multiple openings. Also, I'm going to align them so they stay centered. Don't forget that these openings are 80 by 60. Also, this group and this group is different. And the rest of the openings are 60 by 60. And there we have it. So in this case, I have created a bunch of openings over here, also trying to align this as best as possible. What we have to do in this case is maybe adjust a little bit the representation of the openings, maybe select all the openings, go to the settings of the opening tool, and over here for the symbol, you can notice we got different types of representations we can always use in order to simulate the opening. So maybe we can go ahead, maybe set it to be as no symbol, so it stays a little bit more basic. And now we can say that we have finished solving the waffle type of structure, the waffle type of slab, using the opening tools. Now let's say you want an alternative for the waffle slab, which is not in 3D, but it's simply done just for the 2D representation. You want to simulate these types of openings with your slab tool. You don't really worry about the 3D that much, you just need the 2D representation. How you can do so? Okay, so for this case, what we can do is use a custom type of fill in order to assign it to our slab. And for the custom type of fill, what we can do is select the line tool, start by drawing the symbol we want to create. In this case, it's going to be the openings, 60 by 60 over here. Let's select everything over here, make a copy and make another copy on the other direction over here. Once you are done with the copies, select everything, Ctrl C. Make sure you strictly use the line or use the line tool. That's it. Because if you use polyline or arc or circle, you might have some type of trouble. So make sure to use just the line tool. So once we have everything ready, select it, Ctrl C in order to copy everything, okay? And then options, element attributes, and let's jump into the fields type of window. In this case, what we have to do is create a completely new type of field, which is going to be the symbol field. I'm pretty sure that we covered in depth everything about the fields in the very beginning of this course. So let's go ahead, use the same process, name this as a waffle slab. Press OK, and then press the paste button. So it's going to paste the symbol. Now we need to be careful and adjust this just a little bit. Let's see if we can adjust this to be 1.10. 1.10. Okay, it's not going to work out, so let's set it to 1 the scale. But the strokes, maybe these ones are the ones that we have to actually adjust. And there we have it. So we are going to get some type of pattern which is close to the representation we are seeking. You can even, for example, simply draw one of the openings and that's it. You don't need to really draw the 3 other types of openings. But once you have the pattern completely ready, if everything is looking good, let's make it available with the 3 types of use with options we got over here. Let's press OK. Now, if you want to create the easiest type of representation for the waffle slab, you simply use the slab tool and you simply model this straight away. And then you simply assign the pattern, the custom created pattern, as a cover fill over here. You activate the cover fill option for your slab and then assign the cover fill you just created, which is going to be the waffle slab over here. Let's press OK. And with this, we have created the custom representation we require for the slab. So if you, for example, select one of the nodes adjust it, it's going to completely adjust everything for you. Don't forget that you can always mess around, for example, with the cover fill orientation over here. You can set this to be linked to fill origin, set this option to something else, and press OK. It's going to activate these two extra nodes that you can click in order to adjust, for example, the origin or where your openings will start, and adjust the orientation for your openings. So this is one quick way in order to simulate the waffle slab, but as a result, keep in mind that it's going to be completely solid in 3D. So you can always use 3 different methods for 3 different purposes. I'm pretty sure that the easiest and the most effective one is with the use of the opening tool. So as always, take as much time as you need. Check out the different ways on how we can simulate the waffle slab. And in the next lesson, I'm going to explain to you how we can work with some of the prefabricated types of elements. Right, so having covered different techniques for the waffle slab, let's go ahead and talk a little bit about the prefabricated elements. And this is really simple. We can simply select the object tool, go ahead and use one of the predefined objects we got over here. For example, for the beams, you got multiple types of elements. You also have, for example, the precast double T, which is one of the commonly used elements, especially for parkings and big projects. You got, for example, precast single T. You can always check out multiple of these types of objects. And don't forget that if you need any type of prefabricated element, you can always find everything in external portals, such as, for example, beam objects, where you also have this curved type of steel profile. We can make an example for this one later on. But yeah, you can always search for everything in sites such as beam objects, beam components, and the list goes on. Okay, so you can always, for example, set this to be Revit and search for even more types of prefabricated types of elements. Okay, for this case, let's go ahead with the basic type of element, which is going to be a prefabricated or precast type of slab. You can simply select this object, go ahead and maybe, well, in Mexico we use a Spancrete type of prefabricated system, which is closer to this first option over here. But in your own country, in your own region, you can always set this to be whichever shape you require, okay? And you can also activate the topping type of parameter we have over here and specify the topping thickness over here. We also have the representation materials. You can specify the materials for this slab over here, and pretty much that's it. Okay, so let's go to preview and positioning. This is where you can also specify the dimensions you require for your slab, but this is something that we also can adjust in 3D. So there's no need to worry about this for now. So let's go ahead, press OK. Let's go to the second level for the project, for the example project. Let's press left click and always go ahead and use the shortest span. So I'm just going to position left with one click the element, and then I'll simply adjust this to be right over here. Maybe adjust this to be over here, something as this. And now we can simply select the element, press Ctrl U to create multiple copies, and go ahead and position the prefabricated objects over here. Okay, so it's just a matter of using the objects manually. You can always use your own object. Now, as always, if you want a second alternative or for this element, you can always go ahead and, as always, use the complex profile. If you remember, the profile manager is quite versatile, so pretty much you simply need to draw the shape you require for your precast type of element. You simply draw it and then go ahead and use this with the beam tool. Okay, so as always, take a minute, check out different techniques on how you can work with precast type of elements. And in the next example, I'll explain to you how we can solve the beam and the hollow block type of slab. Alright, so for the next example, which is the beam and block type of constructive system, I'm going to, in this present lesson, I'm going to include these extra two references. one of which is the profile we are going to use for the beam, and one of which is also the profile we are going to use for the hollow block. So you can simply insert these references, extract them, and use the profile manager function to create your custom profile. So pretty much this is the process that we're going to use. This is a custom profile, and this is a custom profile. And then we simply use it, model the block, we model the beam, and then we simply copy and paste everything multiple times. So let's go into ArchiCAD, let's go to the second level over here, and let's drag and drop both of the references that I'm also providing to you. Simply select this element, you can drag it and drop it into ArchiCAD over here. It's going to be a little bit bigger, but it's no problem for now. And let's drag and drop the second reference, which is also the PDF form. Let's right click this, explode into current view, deactivate the keep original elements after exploding option over here so it doesn't create a copy. Press OK. Also explode this one over here. Press OK. And now what we have to do is carefully just select the fill of this reference. So just make sure to activate the suspend group command option over here. Select the arrow tool, select your fill, and simply move this fill a little bit to the right. Okay. Now be really careful if you don't activate the outline type over here, the fill is going to be invisible. If you either select this, it's going to be gone, but it still exists over here. So let's make sure to activate the outline so it's also visible. And let's go ahead, do the same with the second reference, extract the fill over here and activate the outline. Okay. So having created this, now we need to make sure that it's scaled down to the real size, which is for the block, it's going to be 62 and 3 for the width of the block. Okay, so let's select this element. Let's activate the resize command over here. Press OK and left click, and type in the real value, which is going to be 0.623 meters or 623 millimeters. Okay, so it's going to be something real small over here. Just going to move this maybe to the center, and let's do the same for the beam, which is going to be 0.12. Let's activate the resize command, press OK, left click, 0.12. There we have it. And with this we have created the required profiles. So in the next step we input everything as intended. Okay, so having created this, let's go ahead with the creation of the profiles. Let's select the hollow block over here, the reference for the hollow block. You simply need to press Ctrl C. Okay, and now let's jump into the complex profiles, the profile manager. Let's create a new type of profile, which is going to be named, let's make it to be completely new. This one is going to be named hollow block 63. If I remember well, that's the width of the hollow block. Okay, 0.62. Let's set it to something as this. Let's press OK for now. Let's delete this reference and simply go ahead and press Ctrl V. So we don't need to do anything else. You simply paste the profile. Make sure that the origin of the complex profile is set correctly with your reference. Okay, this X over here marks the reference line position for your complex profile. So this is something to keep an eye out. Yeah, it's pretty much set. It's pretty much done. What we have to do is simply select how we want to use this complex profile. Let's make it available with the beam tool over here. And with this, we can simply hit the save button and we have created the first profile. Now let's go ahead and create another type of profile, which is going to be the beam. Let's duplicate this, press OK. So it's going to also give us the reference over here. Let's go back to the floor plan view, select the beam, Ctrl C, go back to the window of the complex profile and simply hit the Ctrl V command. Let's paste this reference over here. And now we simply delete this element and replace it with the beam. Now something that also we need to keep in mind is the field type. We need to specify which is going to be the material. So for this case, how about we set this to be concrete structural over here. Let's make sure that we save this change for the beam, and let's make sure that we modify the material for the hollow block, which is going to be maybe a basic type of concrete or something else, maybe concrete block structural. Let's select this element, let's select this material, and also hit the save button. So with this, we are pretty much done creating the two complex profiles we require for the beam and hollow block system. And now we simply need to create these elements. So let's go ahead, we delete the references. Let's go over here, let's activate, for example, the beam tool over here, and let's configure the beam tool to set the segment. It's going to have a custom type of profile, which is going to be the newly created hollow block. Everything is looking good. Let's press OK. And now let's visualize the depth we require for the hollow block. If we don't have a reference, you can go ahead and maybe use any type of standardized measurement, maybe 25. Let's see how it behaves with 25. Let's go to 3D. And right over here, you can visualize that we are pretty much done with the hollow block. So it's just a matter of copying and pasting this until we cover the whole space we got over here. Now let's go ahead and create the beam. Right over here for the beam, let's use another type of structure or profile, which is going to be this beam we have created. Let's left click, so we position the beam on top over here, extend this a little bit. You can always position this however you see fit, but for this case, yeah, maybe I made a small mistake, so I'm going to select both of these profiles and maybe switch the positioning to be instead of level 3, set this to still be on level 2. Okay, so it's positioned on the correct height. Let's go ahead and start positioning the elements. I'm going to open up the cut section. The beam we have created, let's position this on top over here. Let's select this hollow block, move this around until we position this over here. I'm going to move this around a little bit to position this within the cut section view. So if we jump back to the cut section, and let's go ahead, select the hollow block and position this on top of the beam. Okay, so it's looking good. Okay, so yeah, pretty much it's looking good. And now it's just a matter of copying this multiple times. So what I'm going to do is I'll take a few minutes. I'm going to create multiple beams over here. And for the hollow block, you can always copy this by press Ctrl U. You activate the matrix option over here, press OK, and you can copy this multiple times in both of the directions. You can copy this in the horizontal direction over here. Okay, and then specify the height, and then go ahead and copy this in the second direction. So if you notice, this is the easiest way to create the multiple copies. Maybe not so in 3D, but this is the base on how you can create the system. And there we have it. So it was just a matter of copying this multiple times. And maybe it's going to be much easier in cut section because I tried in 3D and it was a little bit hard. But after all, in short, it's just a matter of creating a custom profile with the profile manager, extruding the elements, and then go ahead and simply copy this multiple times. And as a small tip that I'm going to share with you is if you want to create some type of joint separation or small separation over here, make sure that you never copy the hollow block exactly with the reference line touching the other reference line, because what is going to happen is going to delete the small separation gap over here, and it's going to look as a basic type of prefabricated element. So make sure to leave just a really tiny a separation over here, 1 millimeter, 2 millimeters, something as this, in order for ArchiCAD to simulate this as best as possible. So having said this, take as much time as you need. Make sure to model out the beam and block type of slab. And in the next lesson, we will continue with the last examples for the three-dimensional type of slab and for the custom truss and metal sheet type of roof. Alright, so having solved the beam and block type of constructive system, let's go ahead and model out the space truss slab. And for this case, how about we start off by modeling maybe some type of basic union or shape over here that will work as a sort of union or transition between the column and maybe this slab, okay? And you can also simulate them using simply the column tool. What we have to do is activate the column tool. Let's go ahead and maybe set the height to something small, maybe 30 centimeters. This decision is, as usual, up to you. You can specify whichever measurement you want to use with your project. How about we use maybe the basic type of profile, and also we segment the profile. Okay, so how about we maybe make it 5 centimeters the base, 15 centimeters the transition, the sloped transition, and maybe somewhere around 10 centimeters going to be the connection. Okay, and the connection, let's set it to be maybe circular. This one is going to be, let's make it even a little bit more, might be something as 30. And the profile for the connection is going to be a little bit smaller, so it's something like this. And then even less over here. Let's make it a little bit smaller. The sloped area, I'm just going to set it to be tapered. It's going to start in 41 and maybe end in something as 15. Let's see how it behaves. So yeah, it's looking much better now. We got the connection, we got the sloped area, and we got the base. Okay, so you can pretty much use the column tool with the segmented method to solve the connection or simulate any type of connection you want for your special elements. Okay, so having made the small connection, let's simply go ahead and set it OK, press OK, and simply left click over here, and there you have it. You have the base connection that you can simply go ahead and copy position one on this corner, another one on this one, maybe one more over here, and maybe one more over here. So this connection works as a plate that will enclose the column with this type of connection. And having modeled out a small connection, let's go ahead, use the object tool. Let's go to settings, and right over here we start searching the space truss slab in building structure. If I remember well, you can find it in steel structures folder right over here. And it's just a matter of browsing the different folders. Okay, space frame, this is where you can find many different types of trusses, custom trusses that you can always use with your project. These elements are also parametric, so you can modify them however you see fit. And over here you got also, for example, you got web beams. This is a nice alternative for the block and beam type of constructive system. You can find web beams, you can find a curved variant for this web beam. You can find three-dimensional trusses right over here. And right over here you will find the space frame structure, okay, or space truss type of slab. So once again, as per usual, it's just a matter of messing around with the parameters. You can play around with the number of cells in X direction and Y direction. You got the different measurements, how much you want for your separations, and also the representation in 3D. If I am not mistaken, well, the separation is fixed. This is also a matter of messing around in 3D. So let's first position the object, and then we can start adjusting it. Okay, let's press OK. And let's click on one of the connections. Okay, so we got something as this. And now let's use the 3D view and the 2D view to start adjusting the three-dimensional slab. So you can click on one of the corners right over here, activate the move node command. Now keep in mind that this move node command is a little bit Yeah, it's a little bit heavy even for my laptop over here. So it's struggling a little bit because it's going to pretty much adjust the structure. This is one of the heavy objects, so be really careful on how you mess around with your object, because yeah, it's going to be a little bit heavy for ArchiCAD. How about maybe instead of adjusting it in 3D, we try to adjust it in 2D. So let's see if we can maybe even set the number of cells to be a little bit less, maybe 4 by 4, press OK. So if you notice, it's going to give us less divisions. Let's left click and let's see if we can extend this. So if you notice, in 2D, it's much better and much smoother to modify the three-dimensional type of slab than in 3D, because in 3D it's definitely going to lag just a little bit. So yeah, it's just a matter of messing around. Let's see how many cells we got over here. We got 1, 2, 3, 4, 5, 6, 7, 8. And in y-axis we got 4, 5, 6, 7. So it's 8 by 7. Okay, so let's see if we can make it 8 over here and 7 over here. 1, 2, 3, 4. Yeah, it's 8, and we got 7 right over here. Now we can keep messing around. I'm just going to make sure that this node will be positioned on the connection, and I'm going to adjust this until I see that this node will also be positioned or centered around here. Okay, maybe I can adjust this just a tiny bit over here, and there we have it. We got a much more smoother connection now. So yeah, it's just a matter of messing around. You can click on each of the nodes until you see a nice connection. Or if you want an exact measurement, you can always go to the preview and positioning and input the exact dimensions over here. Okay, so let's press OK. Let's see how it behaves in 3D. So yeah, it's looking quite nice. We got a nice connection going on over here. And then we got the three-dimensional slab. Well, in Spanish we say three-dimensional slab, but in English it's space truss slab or the space frame. Yeah, we can add a little bit of width over here, maybe something as 80. It's going to be a little bit too much, but as always, it's just a matter of messing around. You can always click each of the nodes and also specify vertical size, okay? But my main recommendation here is not to modify this object in 3D, because it's going to freeze, it's going to lag just way too much. This is not too optimized object, so my recommendation is to always modify this object in the 2D floor plan view and then corroborate in 3D that everything fits all together. So having said this, take as much time as you need, make a nice connection over here, and then you can mess around with the three-dimensional object. And in the next lesson, we are going to cover how we can create completely custom types of trusses for the roofing part of the experimental project. Alright, so let's go ahead with our next lesson. For this case, what I'm going to do is include you this extra reference, the custom truss. So make sure to open it up, and you will notice right away we got the profile that we are going to use for this experimental project, which has a total width of 5 meters, the base height, which is going to be 60 centimeters, and then the final height, which is going to be 1.20 centimeters or 1.20 meters. Okay, so we will use this reference 5, 60 and 120, and in order to create this type of custom truss with the use of the truss maker function. So how can you create your first truss? And trust me on this one, it's really easy, and the best part is that ArchiCAD will do everything for you. Okay, so let's go ahead, simply select your line tool over here. Let's simply draft the base, which is going to be 5 meters. Let's draft the first height, which is going to be 60. On the middle, you can draft over here 1.20. Connect this one and this one. Select these two elements, mirror them. Okay, I'm just going to activate the mirror command with a copy. And now what we can do is simply divide this 1, 2, and 3. So let's go ahead. You can select this element, Ctrl U in order to divide, and then maybe distribute 2 extra copies with the -1 parameter active, so it doesn't insert an extra line on the reference. Okay, Let's press OK, left click, and with Control, hold down Control to trim this line over here and trim this line over here. And finally, let's make sure that we create the diagonal connections over here. So let's go ahead, draw one line here and another one here, and the final one is going to be here. Select everything, and finally we can simply mirror everything. Okay, I'm just going to activate the mirror command, and there we have it. We don't even need the reference because everything is simply just with baselines. Okay, so the most important thing when you are working with trusses and the truss maker function is to generate the reference line that will define the main shape for your truss. Okay, and once you have everything ready, what you have to do is simply select everything right over here. And once you have selected your elements, you will go to the menu bar. Let's go to Design. Let's go to the Design Extras over here, and you will find this amazing function called the Truss Maker. You have two options: the Create Truss. This is the one that we're going to use when creating a custom type of truss from zero. And the Edit Truss function is the one you will use once you have created your truss, you position it. If you want to continue editing the truss, you can use this other option. Since we don't have anything created yet, let's go ahead and simply activate the Create Truss function. And if you notice right away, if you activate the truss profiles, ArchiCAD has detected the lines or the shapes you have created beforehand. Now this is where the fun part will begin. You can start specifying which type of section you want to use along your truss. Okay, whether it's going to be some type of timber construction, whether it's going to be completely hollow, or maybe it's going to use some type of custom type of profile. It doesn't have to be in the shape of an H or in the shape of an I. It can be pretty much any of these custom shapes. You can make it I shape, you can even rotate it to be a H shape or I shape over here. You can make a T shape, L shape, you got C shape, double L, double C, or this one that has a circular type of profile. So there are multiple options with the last option. And the hollow section and timber construction, you will notice that it won't allow you to use the steel junctions extra apartment. Okay, so just keep that small detail in mind. You can even vary over here with the hollow section, whether it's going to be a rectangular section or a circular one. Let's go ahead and use the rolled steel profile for this one over here. Let's see what the reference says. If I remember well, it's going to be completely 10 centimeters, 10 centimeters. Pretty much everything is set to be 10 centimeters. So in ArchiCAD, let's go ahead, use the first option. You can specify whether it's the first one, the second one. I leave this decision up to you. If I can notice over here, it's going to be, instead of an H shape, it's an I shape. If we make a cut section over here, we can visualize the shape to be something like this, okay, instead of something like this. So finally, I leave this decision up to you. The main purpose here is to practice this function. So let's go ahead and leave it as it is, 10 by 10. The thickness, okay, sounds reasonable. You can always specify the pen over here, which pen you want to use. With your floor plan and model attributes, you can specify which type of line, which type of surface you want to use with your truss. For this case, how about we use maybe some type of metal. You can specify the displacement. You can also specify the displacement for the story. And this one is the general displacement. And right over here, you can specify on which layer you want to position your truss. Then you got truss profiles. Well, we already covered this one. And then you got something amazing, which are the steel junctions. How you want to use the junctions or the plates for your truss. If the corners will have some type of junction plate, you can activate this option over here, and it will activate the graph that we can see in many structural types of documentation, where the engineers will specify how the plates are constructed. So this is a classical graph, and where you can specify the measurements for each of the reference lines so the plate is created. You can always specify what happens when you are joining two identical profiles, whether you want to use a junction or not. Just going to set everything to be activated so we can visualize the final result. And for the geometry, you can specify how you want to use the midpoints or the center of gravity. You can mess around with these options, okay? So for this case, I'm simply going to activate this first option, and for the corners to also use the plate, okay? So let's press OK. What's going to happen is ArchiCAD will open up where you want to save your custom-made truss. If you notice, it's going to be saved always in the embedded library, okay? And for this case, I'm going to use just a basic type of ID, maybe make it something as truss. Well, in Spanish we call it armaduras, so we use this type of ID. So I'm just going to make it TRS for the truss, something similar as in Spanish, okay? So let's go ahead, save it, and ArchiCAD will automatically position this custom-made object over here. So right over here, it's going to be automatically selected. If you go to the 3D view, you will notice that you have created your completely custom-made truss with just a few clicks. Okay, so it's quite an amazing function. You simply draw the reference line, design extras, and truss maker. And for example, if you select your object, you can always activate once again design, go to design extras, truss maker, and you can activate this option, the edit truss function. Okay, now we'll have a notice over here because it's asking us to open up a section view. So maybe, okay, let's go ahead and create a section over here, and let's open up the section and select this truss. Let's see if we can once again edit the truss over here, continue editing right over here. If you notice, it's going to give us a prompt to insert the reference lines for the truss. And right over here, it has extracted the reference line, so we can once again maybe adjust anything for this custom-made truss. And once again, we can, for example, edit, design extras, truss maker, edit truss. So pretty much it will basically extract the reference line so you can make adjustments for your truss. But the thing is, keep in mind, it only works in the section view. So make sure to open up or create a basic section, because if you try to open it up in the floor plan view, it's going to give you a small notice over there. Okay, so having said this, let's go ahead and simply make sure to position the truss. I'm just going to project maybe the level 2 as a reference on level 3. I'm going to take this reference to position my truss. Maybe rotate this element over here. Go ahead and position this to the center, right over here. It's a little bit offset, so yeah, I'm not going to worry that much for now. How about we maybe center this a little bit better, right over here. And in this case, I'm going to center the truss on this line, okay? I'm going to offset this so it stays on the very right part, something like this, okay? And in the floor plan view, let's see how the reference, how the PDF brochure has the reference. We got one truss here, one here, one here, and one here. So we got 1, 2, and 3 divisions. Okay, so let's go ahead to ArchiCAD, select the truss, deactivate the reference, select the truss, activate the reference, and create the 3 extra elements right over here. Going to deactivate the -1 parameter. So yeah, it's looking good. Let's press OK, and let's see if it's going to create. There we go. So we got 4 trusses in total. I'm just going to maybe set it over here, and now we can say we have created the custom-made trusses over here. Okay, so this is just one of the main examples. So if you are, for example, in Europe or United States, where you want to build some type of gable roof or a hip type of roof, or pretty much many types of roofs that are custom made, you can always use this amazing function to create custom trusses for your gable, hip, or pretty much any type of roofing system you want to implement. Not just for this example, but Truss Maker is an amazing function and quite a versatile one. So as always, take as much time as you require. Make sure to check out this amazing function, and in the next lesson we are going to continue by covering how we will create now the horizontal elements over here, which are the purlins we require before positioning the metal roofing for this example. Alright, so having created the trusses, let's go ahead and now position the purlins or the horizontal beams we need over here in order to finally position the metal sheet roofing for this example. Okay, so let's go ahead to maybe the third level over here, activate the floor plan view, maybe deactivate the reference, and let's activate maybe the beam tool we got over here. And for the type of structure, if I remember, we already imported a custom type of profile in the previous section, which was CE76 by 6.10. Don't forget that you can import your own type of custom profile with the import standard steel profile function we got over here. Okay, so you can use pretty much any type of shape you require for the project. In this case, I'm going to use a C type of shape. Okay, so let's go ahead, maybe start the purlin from a little bit offset, or maybe from the center. We can adjust it later on. Left click over here. Okay, let's press continue. I'm not really sure where the purlin was created, maybe in the second level. So yeah, let's switch this to level 3 and maybe offset this a little bit better. Okay, I'm not going to worry about the position yet, because in order to solve the position as easily as possible, what we're going to do is create a cut section over here to visualize and position the purlin. But for now, we still need to solve the longitude or the length for this purlin beforehand. So let's extend this a little bit over here. Maybe extend this 15 centimeters. You can use a nice trick over here. Just type in 0.15 and the plus symbol. So it's going to simply add up the measurement automatically. Or for example, 0.10 plus, and it's going to add up the measurement to your existing length. The same goes over here, 0.10 and the plus symbol, and then simply press enter. So yeah, now we have the longitude. Let's go ahead and create the cut section view. Let's go to viewpoint, activate the section tool, left click to create a section view over here. And let's go ahead and open up this section view. So yeah, we also visualize a lot of information here. So my recommendation here is, how about we limit the section? Select your section view and activate the limited type of representation. Let's activate this one. So yeah, it's going to be limited to until this line over here. So we don't visualize the three-dimensional slab we got before, but only what we require for this example. Okay, so as you can see, we got the truss over here. Let's go ahead, select the purlin, move this purlin over here up until the very top. Okay, and now for the rotation, what we can do is, first off, let's activate the measure tool we got over here and maybe measure the angle we got for this truss over here. So the angle is 13 degrees. Doesn't fully convince me yet. How about we maybe increase the units, the working units, project preferences, working units, and maybe increase this to 3 units, and the angle unit is also going to be will also has extra precision. Let's press OK. Let's see if we can measure this once again to maybe have some extra precision, and there you have it. It's going to be 13.50 degrees. Okay, so let's go ahead, select the purlin and simply modify the axis rotation. Set this to be 13.50. Let's press OK. Yeah, if it's a positive value, it's going to rotate this profile counterclockwise. So in this case, we can go ahead and maybe input something as negative. Let's see if the negative, yeah, if the negative actually works, so it's going to subtract 360 minus 13.50, and you will get this value over here automatically, which is quite amazing. Let's press OK, and there we have it. So let's simply position the purlin. Let's go to the reference, see how many of these purlins we require. So it's 1, 2, 3, 4, 5, and 6. Okay. Let's go back to ArchiCAD, select the purlin, press Ctrl U, and drag distribute 5 extra copies. Okay, press OK, and let's go ahead and create the operation, the extra profiles over here. From the first point, right on the top, let's simply click the last point or the last corner right on the bottom. And with this, we have created the purlins. And if you notice, it's not that hard. You just need to start off solving the length with your profile, okay, on the floor plan view, and then when you have the length, doesn't matter the position, simply create a cut section view, and in the cut section view you can pretty much solve everything. So having created the purlins, now in the next lesson we can continue and simply position the last element, which is going to be the sloped metal sheet roofing, or the metal sheet roofing with an angle. But beforehand, take a minute, make sure to position correctly all the purlins you require, and in the next lesson we will continue with the other element. Alright, so for the metal roofing we will do something similar as to we already did beforehand, which was for the steel deck. We will actually use the same object we used for the steel deck type of slab. So for this case, let's go back to the floor plan view. Let's activate the object tool. Make sure to navigate to building structures, cladding, and make sure to activate the profile sheet object over here. And for the settings, let's go to profile settings, to style, and make sure to select another type of profile. You can use whichever type of profile you require. In this case, you can even use this one, however you see fit. For this case, I'm simply going to go with the undulated type of profile. Okay, not going to modify the values, just leave it as it is. And let's be careful over here, because if you notice over here, we also need to create the sloped element. If you go ahead and simply press OK and left click, what's going to happen is that it will position, it's going to position the metal sheet, but it's going to be completely horizontal. Plus, you need to keep in mind the direction of the metal sheet. It's not going to be parallel to the purlins, it needs to be completely perpendicular. If the direction of the purlins is something like this, the roofing has to be perpendicularly positioned to the purlin. You can fix this really easy in just 2 steps. Select your object. In first place, in the style, what you can do is modify the pattern angle. If you set this to be 90 degrees, what's going to happen is that ArchiCAD, if you notice over here, is not going to have the undulated pattern on the lateral part of the sheet, but it's going to have it now in the other end. So this is one way to fix it, really easy. And the second one would be the pivot and edge. This is where you can modify the slope. So let's go ahead and set this to be 13.50. So it matches the angle the truss already has. Okay, let's press OK. Okay, so yeah, pretty much is set. Now what we have to do is go back to the floor plan view, rotate this object right over here, and simply go ahead and start covering the area with the metal sheet roofing. I'm just going to cover maybe half of the whole element. Use this object to maybe edit this a little bit over here and set this to maybe be, just for the example, just for experimentation purpose, maybe just cover half of the whole area. Now finally, let's go ahead, let's jump back into the cut section view and select this element once again and make sure to position this on top of the purlins. You can always go ahead and continue editing the object, but yeah, we have a small mistake going on over here, so yeah, we still need to fix this. Okay, so let's go ahead and set the pattern once again to 0, see how it behaves, Yeah, it's pretty much fixed with simply resetting the pattern. So yeah, pretty much we are done. We can say that we are done. Maybe even select the roofing and create some type of extension, extra extension over here, and maybe offset this just a tiny bit. And in the cut section view, make sure that this adjusts exactly on the purlins, just a tiny bit here. So yeah, with this we can say that now we are done with this example. So if you notice, you can use this object to simulate any type of roofing you require for your project. Or for example, if you are creating some type of industrial warehouse where we can see this type of constructive systems more commonly used, you now know how to model this using these simple objects. As always, take as much time as you need. Make sure to practice pretty much everything we have covered so far. With this, we can say that now we are finished with this example, and in the upcoming lessons we will cover just extra functions that go along with this type of topic. Alright, so having explained different functions using the beams, the columns, different examples with the constructive systems, let's comment now a few extra functions we also have in ArchiCAD that might open up new opportunities for you for the generation of substructures, for the generation of specific types of details. And let's start talking a little bit about the goodies for ArchiCAD 27 plugin. This is an extension that you can manually download, you can manually install, and it will open up a lot of different functions within ArchiCAD. For example, you got an amazing tool which is check duplicates, something real useful in ArchiCAD, but also you have the polygon counting tool. You got, for example, the construction simulation, which is a little bit closer to the 4D simulations that you can generate in external software, but using ArchiCAD internally. And for this lesson, what we are going to use is one of the functions, one of the specific functions we got within the accessories and the accessories library. Okay, so first things first, what we have to do is download the goodies plugin. I'm going to include the link so you can download this within the lesson. So just make sure to download it for Windows or for Mac. Just click on the icon over here and the download will start. And once you have downloaded the plugin, you can simply go ahead, right click, run as administrator. Let's give it a second. So now let's simply just go ahead and install the plugin. Let's hit the next button. You can read the license, accept it, okay. Then you can specify the folder where you want to install the plugin. Let's hit the next button. And right over here you can install different functions, different extensions you can select. You can, for example, select only specific ones, such as maybe duplicates, but you can simply go ahead and check up all the different extensions. For this specific lesson, make sure that you definitely install the accessories, something that we are going to use in a little bit. Let's go ahead, press next, and simply hit the install button. And pretty much that's it. So it's going to install in just a matter of seconds because it's just a basic extension. Let's hit the finish button, and now let's take a moment to start up ArchiCAD. Alright, and once you have booted ArchiCAD, this is where the fun will begin, because now what you can do is activate the object tool, and let's go to the object settings, okay? Now before we begin, something that we have to make sure is that we have the newly installed library booted up. You need to have one extra folder which is going to be the accessories library. Okay, if you already have it, that's pretty good, but if you don't have it, such as would be in my case, you can simply go ahead, click over here, make sure to open up the library manager, and let's add up a new library, which in this case is going to be the accessories library 27, which you can also locate in your ArchiCAD installation folder. Right over here you got the map library, you got the ArchiCAD library, and also the newly one which has been added with the plugin would be the accessories, okay, which is just a really small library. It's not more than 2 megabytes. So let's add this up, press OK. And now once you have added the accessories library, let's check out which accessories we get. So you have the ceiling object, which is quite useful. You can also go ahead and use ceilings with ArchiCAD. you got floor structures, you got some type of special footing object, which also works as some type of continuous footing instead of the techniques that we already covered. You can also go ahead and use this as an extra alternative. You got roof accessories, such as, for example, this metal sheet object. You got slab accessories, and you also got wall accessories, which one of which is my favorite object, which would be the wall framing object. And this object is quite amazing because you can also combine it, for example, with a specific function, something we're gonna comment in a little bit, but make sure to check out the different accessories you get in your new library. So let's go ahead, press OK, maybe just create one of these objects. Now I want to point out, I'm not going to explain everything about the goodies. This is just a quick review of the main function that I want to share with you as an extra. So you can, for example, select this object, open up the parameters, and start adjusting, for example, the wall framing settings, which are, you will notice that there's a bunch of settings that you can also mess around. You got the stud size, the header size, the distance of the stud centers, you can specify them over here. And you can also, for example, click on one of these nodes and start adjusting different parts for your objects. For example, you can create new studs, okay, or new parts. You can click these ones over here and start adjusting the object. But the best thing is that you can pretty much integrate this object with your volumetric model. So let's say you have some type of drywall system you are using for your interior partitions, or gypsum board system, or you have some type of Duroc system, or maybe cement board, and what you want to create is a substructure that will position each of these boards. So let's say, for example, let's maybe go to the ground floor. Let's go ahead and maybe create some type of basic wall, which is going to have, for this case, let's say it's going to be drywall. I'm going to use 90 millimeters. Press OK. Let's simply draw something basic, such as maybe 6 meters over here. Let's go ahead 3 meters over here, another 3 over here, and maybe 3 here, and let's connect everything. Okay, so what you can also do is create some types of openings. Let's say we create a basic door over here, which is going to be some type of office, or maybe let's go ahead, position some type of storefront over here. And let's create a few windows, few openings, which are also going to be fixed glass. Press OK. Maybe position one over here, and maybe let's say one more over here. So now the best thing is that you can select all the walls, or select everything, and you can simply go over here to design. Let's go ahead with design extras, and in accessories folder you got roof accessories, slab accessories, wall, and polyline accessories, which basically what they're going to do is combine the library parts we have just reviewed, such as, for example, the continuous footing. You got roof accessories such as the metal sheeting, you got slab accessories, or the framing object we just reviewed. For this case, we want to apply one of the wall accessories for our wall system. So let's go ahead, wall accessories. Let's go ahead and select which accessory we want to use with this wall, or we want to incorporate, which is going to be the wall framing object. Let's set this to be maybe instead of some type of wood system. Well, if you want to use maybe some type of styrofoam, or maybe some type of interior insulation with some type of wood panel, you can go ahead and set this to be a frame made of wood if you are using some type of specific system. But in this case, I want to simulate maybe some type of drywall, so I'm just going to set this to maybe aluminum. Okay, and maybe let's go ahead and the distance, adjust this just a little bit. Feel free to adjust the parameters for this object however you want. It will depend upon your constructive system in your own country as per usual. So let's go ahead, press OK. And this is a fun part. Simply press left click on the outside. And this is how, if you notice, it's going to get something a little bit messy. And this happens because if you notice, it's going to position your object, but it's also going to give you a 2D preview of this object in the ground floor. So you can select also each of the studs. You can start adjusting the frames. Let's see what happens in 3D. And this is the best part because it will automatically detect the openings. Let's, for example, select maybe the wall and hide the selection. So if you notice over here, it automatically detects the openings such as the wall and the window, and it's going to create automatically the substructure required to mount the different gypsum boards. So this is quite an amazing function that I highly would recommend that you take some time to check out, to take some time to analyze and to study. And the best thing over here, let's say, for example, let's show everything once again, is that the changes are not final. For example, you can select your window, you can adjust this a little bit, let's make it a little bit wider, and if you notice over here, the substructure has been automatically adjusted to your new opening. Now keep in mind that yes, you will get sometimes some type of weird stuff going on over here, and right over here what you have to do is maybe start adjusting this manually, maybe create a manual type of opening over here. So yeah, it's not perfect, but it will save you a lot of time. So this is one function that I highly recommend that you take some time in order to check out. And keep in mind, I'm just going to comment this, but don't forget that you also have extra accessories. You got roof, slab, wall accessories, which you can always implement with your newly added library objects. For example, you got the ceilings, you got the roof accessory, which is this metal sheeting, which is something that I highly recommend that you also check out. So as always, take some time, check out this amazing function, and for the next lesson I'm going to explain to you another amazing function. Now, besides the ability to create substructures within your walls, whether it's going to be metal or some type of wood, you can also create substructures for your roof. And let me demonstrate. For example, let's activate the roof tool over here. Let's make it some type of basic type of structure over here. And let's set the, maybe the thickness a little bit less. Let's make it 35 degrees in angle. And in multiplane geometry, the offset, let's keep it maybe half of that value. So let's press OK, and let's maybe create some type of L-shaped type of roof. So I'm going to start maybe with some type of rectangle over here, and let's add maybe one extra part for the roof right over here. Maybe it's going to be 10 meters by maybe 8,500 millimeters. Let's do something like this. Okay, now I'm going to take a minute just to maybe a few seconds to maybe adjust a little bit the construction for this roof. So we got a nice looking roof right over here, which has a nice geometry. Now, the most amazing thing that ArchiCAD also will offer to you is the possibility to create a roof structure or substructure with the use of the roof maker function. Now, the function is already integrated within ArchiCAD. The only thing you have to do is go to design right over here, roof extras, and you will notice that you got the roof maker option right over here. And there are a bunch of functions that we can take a minute to comment. But first things first, in order for this function to work well, I would recommend that you go ahead and open up the ground floor view right over here. So once you got the ground floor view, let's once again select the roof we got over here, design, and design extras, I mean roof extras for this case, roof maker, and if you notice we got a bunch of options. Now from create rafter up until create I-beams, all of these functions will allow you to position each part manually, each part individually. It's quite useful once you create automatically the structure you want to use and you want to fine-tune the substructure, so you can go ahead and create extra tie beams, extra color beams, purlins, streamers, rafters, etc. But for this case, the two options that we want to use are the Roof Wizard in first place, and in second place the Show Roof Maker Toolbox option. So let's go ahead with the Roof Wizard in first place, And this is an amazing function that will pretty much automatically detect the geometry you got over here. And you can start adjusting which type of shape you want for your rafters, the cross section, the eaves angle. If you want to activate the soffit parameter, specify angles, or the connections. There are just many parameters that you can always check out. For the beams, a group, you can also specify the displacement, the different measurements for the width, the height, how you want to specify whether the color beams, the tie beams, different details that you can specify for the beams. The same goes for the purlins. You can go ahead and specify the shape you want for your purlins and mess around with the different parameters. Same for the trimmers, whether you want to create or not create trimmers, if you want to position them perpendicular or in a vertical position, and which size you want to use, okay? And also you got the different ridges, whether you want to use specific sizes. Everything is, you can specify everything in the roof wizard settings. So for this case, I'm not going to modify anything. Let's simply go ahead, press OK. And if you notice, ArchiCAD, this is quite an amazing function because if you notice, it automatically will create, for one instant, let's show everything. And right over here, let's go ahead and maybe hide the roof in first place. But now you can notice how ArchiCAD has completely, in an automatic way, has created a completely new substructure. So this is quite an impressive function that you can also mess around. You can also use. Let's maybe make another example. Maybe I'm just going to create something more basic. Let's select the roof in 2D. And let's go ahead, design, roof extras, roof maker, roof wizard. And let's see if we got everything on. Let's press OK. See how it's going to behave for this case. And let's hide the... okay, let's in first place show everything. And now let's hide just the geometry. Okay, so if you notice over here, notice how it's going to automatically position this structure and everything has been automatically created. Now, if you want to continue adjusting everything with the roof maker function or create elements manually, what you can always do is, for example, go to design once again, roof extras, roof maker, and yeah, just keep in mind that this function won't work in 3D. This is just a small detail to keep in mind, so you have to always go to ground floor, and this is where you will work your substructure. Okay, so once again, design roof extras, roof maker, and let's activate the show roof maker toolbox. So this is going to be just pretty much the same, but this is a floating palette that you can position anywhere you want. But right over here you can start creating extra rafters, multiple rafters. You can create purlins, you can create trimmers, pretty much all the functions you can find them over here. And you also got the roof wizard over here, but you have to select one roof in first place for it to work. So let's go ahead and maybe select this roof once again. Let's activate, for example, the create a rafter. Let's select one of the planes and let's press OK. You can specify which type of rafter you want to add. Once you specify the details, go ahead, press OK, and specify the position for your newly created rafter. And right over here, you can notice how ArchiCAD, based upon the geometry of the roof, have created a new part for your substructure. So as always, take some time, check out this quite amazing function. This is just, I'm not going to explain this in the whole detail, but this is pretty much just a matter of messing around with the parameters. And for the next lesson, we can continue covering extra amazing functions we also got with ArchiCAD. Right, and something extra I want to also comment is the ability to create steel reinforcement or specific solutions with the integration of the different EPTAR solutions, okay? Now, I want to clarify these solutions are paid. So yeah, they are not going to be for free. This is something that I had the opportunity to try out long ago in the Spanish version of ArchiCAD. But right over here you can, for example, click on the EPTAR Reinforcement 5 add-on for ArchiCAD. You can download the newer version, but pretty much you will have the ability to create steel reinforcement for all your different beam elements. Okay, now this is just going to be a voiceover over a video that I have created long ago explaining just the main points for this EPTER solution. But pretty much you can, for example, model out, let's say you got some type of isolated footing, you got your beam, you got your different connections, and you can create with practical tools in a specific library pretty much the steel reinforcement you require for this footing. And the best part, you also got in the right, you got this floating window where you can pretty much select which element you want to work with, whether it's a beam, whether it's a slab, it's a wall, and you can also apply automatic solutions in the same manner we already did in the previous lessons, where you select your element and almost instantly create your amazing substructure. Okay, in this case the steel reinforcement. Now something else I want to comment about EPTER is that yes, it will also have its specific library where you can position each of the different elements manually. You can position rebars, you can position meshes, you can work on edges, you can work on your stirrups, on your longitudinal bars. And for example, if we select one of the objects, you'll notice we got many different parameters that you can mess around, play around in order to specify the object you want to use for your steel reinforcement. And the best part is that pretty much when you get the reinforcement ready, you can also integrate amazing functions such as, for example, the cutting list. Just with one click, you can left click just once, and it will automatically give you a list of the different stirrups, rebars, and all the steel that you use for your structure. It will tell you which diameters, it will tell you the length, how many pieces, and also it will give you a total weight of kilograms of steel you use for your reinforcement. So make sure to check out this EPTER solution. As I already mentioned, it's a paid solution, it's not free. It also has its free trial for a limited time, but I believe that it's one of the best solutions in terms of steel reinforcement. Not the only one, there are of course different free solutions, but in my perspective I think that this is probably the best solution or add-on for ArchiCAD. And with that, we have wrapped up our small experimental project along with the review of additional features that you can always explore further to achieve even more solutions. As you have seen, there's a bit of everything, but you can also combine conventional techniques with several specific objects that will help you solve structural and constructive systems within ArchiCAD. For the next module, we'll begin with an introduction to Map Modeler, a feature that allows you to model and develop all types of installations for your BIM project. Don't forget to take a short break before starting and continuing with the next session. And without further ado, I'll see you for the next module.